Before I show the circuit, maybe I should discuss a bit about diode for benefit of those who are not familiar with diodes. This is the symbol of the diode. For the diode to work, we need at least 0.6 or 0.7, roughly around this value, across the diodes. So it means that if this end of the diode, let's say if it's 4 watt, then this end has to have 4.7 watt for the current to flow. If we have 4 watts here, and then we have 3 watts here, then this diode will not conduct. So it's an open circuit, or look as if it's an open circuit, meaning that it has very high resistance. So you can think of this diode as a switch, meaning that if I have a voltage on one end higher by 0.7 watts, then my diode switch on, then current flow through it. If the voltage is lower than 0.7 watt of the other end, then the switch is turned off, then currents cannot flow. When it's turned on, the voltage drop across the diode is roughly about 0.6 or 0.7, meaning that if this end is 4 watts, the other end will be 4.7 or 4.6 or 4.7, regardless of how much voltage you applied to it. It will have 0.7 watt drop across the diode. And the current flow is very large across the diodes. So it's almost like your mechanical switch. If you turn it on, the current is purely just depend on how much the current in the circuit itself. It doesn't depend on the switch. The same thing for the diode. When the diode is turned on, then the current is depend on how much current actually flowing in the circuit rather than depend on the diode itself. Okay, so that is a very simple term in how diode is operate. So on one end has to have 0.7 watt higher compared to the other end. So in this case here, the positive side has to have 0.7 watts higher than the negative side of the diode. Okay, so back to our circuits. I'm just going to look at one branch of the one that you're given. So you're given a diode like that, and then a resistor, and then 12 watt voltage, 1K resistor, and then here you're going to apply either a 0 watt or a 5 watt. Then we're going to measure this point here. So this is, in your experiment, you're going to put that through an LED to see whether it turns on. For simulations, we're going to put a wattmeter here to measure the voltage. Okay, so that is how I'm just looking at one branch of that. Okay, so in your circuits, you have 3 diodes in parallel. So I will discuss about how this operates here. Okay, so and I mentioned here it needs 0.7 volts higher on the other end for the diodes to operate. So if you look at this circuit, I have 12 watts supply here, meaning that this side, this point here, is always greater than the 5 volts. Okay, so both 0 and 5 volts at this point is always greater than this because we got a 12 watt supply here. So if it's a 0 watt, then I will expect 0.6 or 0.7 volts at this point here. Okay, so if I put a 0 watts on this side, so if I measured the point, the knots at this point, using a wattmeter, this should show up 0.6 or 0.7 volts. And then current will flow in this direction. If I put a 5 watt, then I will get 5 watts. So this side 12 is still higher than 5, but the diode forced the voltage drop to be 0.7 or 0.6. So at this point here, you get 5.6 or 5.7 volts. Okay, so this measured about 5.6 or 5.7 volts. So means that if I put a low, I'll get a low. If I put a high, I'll get a high in a single branch diodes. Okay, so if you have more than one branch, then you can deduce what you're going to expect. And then you can see whether the diode is open circuit or short circuit, depending on the voltage on both ends of the diodes, based on this principle here. Okay, so basically that is how the diode is operate. So the 1K resistor is to limit the current, because we said that the diode, when it turn on, it can flow as much current in the circuit, so it doesn't restrict current flow. So if you don't put a resistor, you put a 12 watt directly to a diode, so then the current will be very high, and then you might burn the diode itself. Okay, so the 1K resistor is to restrict the current based on Ohm's law. So that is the theory behind it. And now we're going to look at how we're going to simulate this circuit in Simulink. Okay, we need a diode, resistor, and the voltage. So if I go back to my library browser, let's do a quick search on diode. You can see that now the top menu is shown as Simscape. So it's only Simscape has diode related components. Okay, let's type diode, put it out onto my Simulink window. The diode that we have just now in that diagram is pointing towards the left. So let me flip this, right click, rotate and flip, and then I'm going to flip it left, right. Next, we want the resistor. The resistor here, let's take it out. You can wire it. Take one end, connect it to my resistor, and see that it doesn't connect. So even if I lift there, you can see that this is a red line. Dotted means that the line is not connected. So if I go back to my browser, you can see that the resistor that I picked up just now is in from RF block set. This is part of Simulink, and our diodes is part of Simscape. So we need components within the Simscape so that it can interconnect. So here's another resistor. It's in the Simscape. So if I take this out, let me rotate this. Okay, you can see that now it's a blue line. It can connect between the two components. Okay, just to illustrate that Simscape component cannot be connected to the Simulink component. So only those components within the Simscape menu that can interconnect with each other. So let me remove this. Okay, next we need a DC voltage source. So we can't take the source from here. So we have to go back to our Simscape. Foundation library, electrical. You can see that there's electrical source here. So we want a DC voltage source. Then connect this. And then next we need a ground reference. So we can go Simscape, electrical, and then connectors and reference. We can pick up an electrical reference. Okay, so that is the circuits that we have. We have a diode, a resistor, and then a DC voltage source. So we want to be able to send a signals into the inputs, and then we want to be able to measure the output from this point here. Okay, so if I go back to my electrical source, and I want to be able to control this input. Okay, so what I need is a control voltage source. So let me take this out. Then you can connect this to a diode. One end, I'm going to connect it to ground. And then here we want to be able to read out the outputs. So we need electrical sensor. So in electrical sensor, we have two components. One is a current sensor to measure the current, and the other one is a voltage sensor to measure voltage. Okay, so we got a source here. We got a sensor here to measure the voltage, and the source here can be controlled by this pin here. And then we can read out the value of the sensor from this pin here. to control this voltage source, we can use the component from that we have previously. Okay, so go back to our Simulink source. We can take our constant voltage source. Then we can take the sink from the display what is on the voltage sensor. Okay, so now we can try to connect this. You can see that again, it cannot be connected, as I mentioned previously. Simscape component cannot be connected to Simulink component. So how do we connect these two up? To do that, we need a converter. So if you go back to Simscape, we go to Utility. You can see that there are two converters here. One is called PS to Simulink, and then one is Simulink to PS. So the components inside Simscape is called physical signals, which in short is PS. In order to connect my Simulinks to my Simscape, I'll need a Simulinks to a PS converter. I can connect to one end of my converter, and the other end I can connect to my Simscape component. Similarly here, we want the other way around, from physical signals to Simulink. That's a setup of my circuits using one branch of the diode. Make this to run 1 seconds. So if I click on run, okay, so you get a list of error coming out. Okay, so what this error is that solver configuration block. So no solver configuration block connected to the physical network. So to simulate my physical signals block or my Simscape components, we need something known as solver configurations. So I'll go back to my library. Again, under Simscape Foundation Library. Oh no, it's under Utility. Okay, Simscape Utility. You can see that here we have a solver configurations. So in order to simulate the physical signals, we need to put a solver configurations connected to the circuits. So this block has to be connected to the circuit. It can be any part of the circuit. It doesn't matter. I can connect it to here, connect it to here, 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 or here. It makes no difference. It just need to be connected. Okay, if I do that, then it should simulate. Okay, again, I haven't configured the default value. No, the circuits is all in the default value. I haven't configured it to what I want. So the resistor, I need 1 kilo ohms. The DC voltage, I need 12 volts. And then here, I want the input to be 0 or 5. Okay, so start with 0. So if I simulate it, okay, get 0.6 volt. So I got 0 here. I get output of 0.6 volt. I put a 5 watt here. I should expect about 5.6 volts here. That's what I've discussed previously. Okay, so I've got 5 watts, I get 5.6 volts. You could also use the pulse generator and the scope here to do the same thing as well, like what we do in the digital circuit or the digital gate. So if I go back to my source, I can put the pulse generator here. Okay, I can configure it. 1 second, pulse with 50%, and then delay, let's say 0.5. It's time-based. Okay. And then here we can put it to a scope. Okay, so I can create 2 ports so I can see what's in the input and what's in the output. Can name this as my input. This is my output. And then because our period is 1 second, so let's run it over 2 seconds. Okay. So we want it to be 5 watts instead of 1. Okay, so amplitude is 5. Okay, so this shows you the outputs, the input and the outputs of this circuit. Okay, so my input pulse is 0. Output, I get about 0.6 watts. And then when the input is 5 watts, I get about 5.6 watts. From digital circuits point of view, so this is low, this is high. And the other difference between your Simulink simulations and these physical signals, you can see that there is a time delay in the diodes. Okay, so you can see that there's a slight delay from low to high, same from high to low, because the diodes will conduct or start to conduct at a certain voltage level. Okay, so this is the simulations, how you can go about simulating diodes and electrical components elements in Simulink. Okay, so that's how you can set this up, and you can use this to simulate any of your electronic circuits that you learn in other modules, for example, in circuit theory or in electronic principle or so forth. And this is how you can set it up to work out the results in the circuits if you want to.